Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive tutorial on Spring XML configuration. This will be a long one, but we'll cover the core aspects with explanations and code examples. Table of Contents *. 1. Introduction to Spring XML configuration. 2. Setting up a Spring project, maven/gradle. 3. The basics, beans element and bean definition. 4. Bean scopes, singleton, prototype, etc. 5. Dependency injection, d. * constructor injection. * setter injection. * field injection. 6. Autowiring. * byname autowiring. * bytype autowiring. * constructor autowiring. * autodetect autowiring. * no, default, autowiring. 7. Bean lifecycle methods, initialization and destruction. 8. Collections in Spring XML, lists, sets, maps, properties. 9. Importing and including XML configuration files. 10. Using property placeholders. 11. Advanced configuration, bean aliases, bean inheritance. 12. Limitations of XML configuration and transitioning to Java config/annotations. 13. Example code, a complete scenario. 1. Introduction to Spring XML configuration. Spring XML configuration is the traditional way to define beans, objects managed by the Spring container, and their dependencies within an XML file. It provides a declarative approach where you describe what you want to happen rather than how. The Spring container then takes this configuration and creates, configures, and manages the beans. Key concepts *. Beans * objects that form the backbone of your application. These are the classes you want Spring to manage. * Spring container, application context, the heart of Spring. It reads the XML configuration, creates the beans, and manages their life cycle. * Dependency injection, a core principle where beans receive their dependencies, other beans they need, from the container, rather than creating them themselves. This promotes loose coupling and testability. * Inversion of control, IOC, the broader principle where the framework, Spring, controls the creation and life cycle of objects, rather than your code. D is a specific type of IOC. Pros *. Clear separation of concerns. * Configuration is separated from code, making it easier to change bean definitions without recompiling. * Declarative. * You specify what needs to be done, not how. * Centralized configuration. * All bean definitions are in one or more XML files. * Traditional and well understood. * A lot of legacy Spring applications rely on XML configuration. Cons *. XML verbosity. XML can be quite verbose and repetitive, especially for large applications. Type safety. Configuration errors may only be discovered at runtime, as XML doesn't have compile time type checking. Refactoring challenges. Refactoring Java code may not automatically update XML configuration, potentially leading to errors. Decreasing popularity. Java-based configurations and annotations have become the preferred method. 2. Setting up a Spring project, maven/gradle. Let's start by setting up a basic Spring project using Maven. Gradle is very similar. Maven pom.xml*. Explanation *. Dependencies, we include the Spring context dependency, which provides the core Spring container functionality. Also JUnit for testing. Properties, we define the Spring version in a property to make it easier to update. Directory structure *. 3. The basics, beans element and bean definition. The root element of your Spring XML configuration file is beans. Inside it, you define individual beans using the bean element. Beans.xml*. Explanation *. XML schema *. The XMLNS, XMLNSC, and C schema location attributes define the XML namespaces and schema location. This tells the XML parser how to validate the file against the Spring schema. It is crucial to include the correct schema location. Bean element *. A unique identifier for the bean within the Spring container. You'll use this ID to retrieve the bean from the container. Class, the fully qualified class name of the bean. Java class mybean.java*. Loading the Spring configuration and using the bean *. Explanation *. Application context, the interface for the Spring container. Class path XML application context, a concrete implementation of application context that loads the configuration from an XML file located on the class path, example in the src/main/resources directory. Context.getBean, mybean, retrieves the bean with the ID mybean from the container. You need to cast it to the correct type. Running the main class will output *. 4. Bean scopes. Bean scopes define how many instances of a bean the Spring container creates and manages. Here are the most common scopes. Singleton, default the container creates a single instance of the bean, and all requests for that bean return the same instance. Prototype *. A new instance of the bean is created every time it's requested. Request *. Only in web applications, a new instance is created for each HTTP request. Session *. Only in web applications, a new instance is created for each HTTP session. Application *. Only in web applications, a new instance is created for the lifecycle of the web application. WebSocket *. Only in web applications that use WebSockets, a new instance is created for the duration of a WebSocket session. Example, beans.xml. Usage *. 5. Dependency injection, DI. Dependency injection is a fundamental principle in Spring. It's the process of providing a bean with its dependencies. Spring supports three main types of DI. Constructor injection *. Dependencies are provided through the beans constructor. Setter injection * dependencies are provided through setter methods. Field injection * dependencies are injected directly into fields, less common with XML. Example classes *. 5.1 Constructor injection *. Explanation *. Constructor arg specifies an argument to be passed to the constructor of the bean. Value, a literal value to be passed as the argument. Ref, a reference to another bean defined in the XML file. Spring will inject that bean into the constructor. When using ref, Spring resolves the other bean and passes it to the constructor. 5.2 Setter injection *. Explanation *. Property, specifies a property to be set on the bean. Name, the name of the property, which corresponds to the setter method set dependency. Ref, a reference to another bean. 5.3 Field injection, discouraged with XML. While possible, Field injection with XML is less common and often considered less desirable than constructor or setter injection because it can make unit testing more difficult. It requires the setter method to be present even though the intention is to set the field directly. This example is identical to setter injection in XML. The maven class must have a setDependency method. However, with annotations, we can use autowired above the field, which achieves field injection directly. Important note: choose constructor injection for required dependencies and setter injection for optional dependencies. Constructor injection ensures that the bean is fully initialized when it's created. Usage *6. Autowiring. Autowiring lets Spring automatically resolve and inject dependencies based on type or name, reducing the amount of explicit configuration you need to write. While convenient, overuse of autowiring can make your configuration less explicit and harder to understand. The autowire attribute can have the following values: no, default no autowiring. You must explicitly define dependencies using constructor arg or property. *byname Spring looks for beans with IDs that match the property names of the bean being created. *bytype Spring looks for beans of the same type as the property being injected. Constructor similar to bytype, but applies to constructor arguments. Autodetect deprecated tries constructor first, then bytype. Use with caution and understand its behavior. Example *. 6.1 Byname autowiring *. Explanation *. Autowire equals byname. Spring will try to find a bean name dependency and inject it into the dependency property of autowired. The constructor argref equals another dependency / is still explicitly provided in the constructor. 6.2 Bytype autowiring *. Explanation *. Autowire equals bytype. Spring will look for a bean of type dependency and inject it into the dependency property of autowired. There must be only one bean of that type in the container. If there are multiple, Spring will throw an exception. 6.3 Constructor autowiring *. Explanation *. Autowire equals constructor. Spring will try to resolve the constructor arguments of autowired by type. It needs to find a bean of type another dependency and another of type dependency. Important notes about autowiring *. Be explicit * favor explicit dependency injection over autowiring when possible, especially in large projects. It makes the relationships between beans much clearer. Conflicts autowiring can fail if there are multiple beans of the same type or if the bean names don't match the property names. Overriding you can override autowired dependencies with explicit property or constructor arg elements. Explicit configuration always takes precedence. At primary annotation you can use the at primary annotation on one of the candidate beans of the same type to resolve the conflict. 7. Bean lifecycle methods, initialization and destruction. Spring allows you to define methods that are called when a bean is initialized, after all its dependencies have been injected, and when the bean is destroyed, before the bean is removed from the container. Ways to define lifecycle methods *. 1. Using the init method and destroy method attributes in bean *. This is the traditional XML way. 2. Implementing initializing bean and disposable bean interfaces *. Less common, tightly couples the bean to Spring. 3. Using @post construct and @predstroy annotations *. More modern approach, but requires enabling annotation processing. Example, using init method and destroy method. Beans.xml *. Usage *. Output *. Important asterisk. Asterisk the destroy method is only called for singleton beans and when you explicitly close the application context, using context.close. Prototype beans are not managed for destruction. Asterisk the configurable application context is needed to have the close method. 8. Collections in Spring XML, lists, sets, maps, properties. Spring XML allows you to configure collections, lists, sets, maps, and properties, as bean properties. Example asterisk. beans.xml asterisk. Explanation asterisk. Asterisk list, set, map, props, used to define the collection types. Asterisk value, for simple values, like strings. Asterisk entry, for map entries, key value pairs. Asterisk prop, for properties entries, key value pairs. Usage asterisk. 9. Importing and including XML configuration files. For larger applications, you'll often want to split your XML configuration into multiple files for better organization. Spring provides two ways to do this. Import imports another XML configuration file, merging its bean definitions into the current configuration. Include less common, and not a standard Spring element. This usually refers to an XML schema feature for including other XML fragments, not directly supported by Spring in the same way as import. Example asterisk. Let's say you have two files, beans.xml, main configuration, and dependencies.xml, defining dependency beans. Dependencies.xml asterisk. Beans.xml asterisk. Explanation asterisk. Asterisk import resource equals dependencies.xml/. This line imports the dependencies.xml file, making the beans defined in that file available in the beans.xml configuration. The resource attribute specifies the path to the file, relative to the class path. Usage, same as before. Important asterisk. Asterisk the resource attribute can be a relative path, relative to the XML file containing the import element, or a class path resource path, prefixed with class path. Asterisk be careful about circular dependencies when using imports. Avoid situations where file A imports file B, and file B imports file A. 10. Using property placeholders. Property placeholders allow you to externalize configuration values, like database URLs, usernames, passwords, into a separate properties file and reference them in your XML configuration. This is a good practice for managing environment-specific settings. Application.properties asterisk. Beans.xml asterisk. Explanation asterisk. Asterisk XML context equals http://www.springframework.org/schemas/context, include the context namespace in your XML file. Asterisk context property placeholder location equals classpath application.properties/. This tells Spring to load the application.properties file from the class path. $database.url, a placeholder that will be replaced with the value of the database.url property from the properties file. Java class, example. Beans.xml, continued. Usage asterisk. Output asterisk. 11. Advanced configuration, bean aliases, bean inheritance. Bean aliases allow you to define multiple names, aliases, for the same bean. This can be useful for providing different ways to access a bean. You can now access the bean using context.getBean, myBean, context.getBean, bean alias 1, or context.getBean, bean alias 2. Asterisk bean inheritance. Templates allows you to define a parent bean with common configuration and then create child beans that inherit from the parent and override or add specific properties. This reduces duplication. Asterisk abstract equals true, indicates that the base bean is a template and cannot be instantiated directly. It's only used as a parent for other beans. Asterisk parent equals base bean, specifies that child bean 1 and child bean 2 inherit the configuration from base bean. 12. Limitations of XML configuration and transitioning to Java config/annotations. While XML configuration has been a mainstay of Spring, it has limitations. Asterisk verbosity. Asterisk XML can be very verbose, especially for complex configurations. Asterisk type safety. Asterisk XML configurations are not type safe. Errors might not be caught until runtime. Asterisk refactoring. Asterisk refactoring. Java code may not automatically update XML configurations, potentially leading to inconsistencies. Asterisk maintenance. Asterisk maintaining large XML configuration files can be challenging. Java config and annotations. Asterisk Spring provides alternative approaches to configuration using Java config and annotations, which offer several advantages. Asterisk conciseness. Asterisk Java config and annotations can significantly reduce the amount of configuration code. Asterisk type safety. Asterisk Java config provides compile time type safety. Asterisk refactoring support. Asterisk Java IDEs can refactor Java config code more effectively than XML. Asterisk testability. Asterisk Java config is easier to test than XML. Example, using Java config. Example, using annotations. 13. Example code, a complete scenario. Let's put everything together with a slightly more complex example, a service that uses a repository to fetch data. Classes. Asterisk Java